Okay, so we have a new triangle type problem. We have our two sides labeled and we have an angle labeled. Yesterday we did problems where we had two angles or three angles. Those are easy to calculate since we know all three angles of a triangle add to 180. So if I try to set this problem up from yesterday using the law of sines, I would get the sine of angle A, which I don't know, divided by its opposite side, equals the sine of angle B, which in this case I don't know, divided by its opposite side, equal to the sine of angle C, which I actually do know to be 42 degrees. But I don't know its opposite side. So here we have an issue. Not one of these three ratios can be simplified to then solve for any of the missing pieces. So the law of sines cannot be used here. However, we also have something called the law of cosines. Now the law of cosines starts out very similar to Pythagorean theorem. We have c squared equals a squared plus b squared, and there's a reason why I'm writing it somewhat backwards from the way you usually hear it. But we can subtract from that 2 times the product of a, b, and the cosine of c. Now don't get hung up on what the letters are, they can be interchanged. So if, for example, if I didn't know what a was, everywhere I have an a, I would now replace it with c and vice versa. So I could also write it this way. But because I'm trying to solve for a, this would now be the angle. So the law of cosines, one of the two situations when you'll use this is when you have two sides and the angle that is between them. That's one of the two instances. So with this example, I don't know what C is equal to, but I know A is 7, I know B is 11, and then I'm going to subtract from that 2 times A times B times the cosine of the angle of 42 degrees. I can actually solve all of this in one step in the calculator. If I remember that to solve for C, I'm just going to go ahead and square root this whole answer. So that can be typed into the calculator in one step. Second squared to pull up my square root, and then I just go ahead and type in each of my values. Again, make sure that you are in degree mode, not radians, or everything will be incorrect. So when I get the answer for C, normally you round it to the nearest tenth. So in this case, I could say C is equal to approximately 7.5. And I'm going to go ahead and plug that back in to my triangle. Now that I've solved for C, I can go ahead and solve the rest of my triangle using the law of sines. What I should also be able to realize is if 7.5 is between these two, then angle A will be the smallest, since 7.5 is the middle side. 42 will be the middle angle. So I'm going to go ahead and solve for angle A. Sine of 42, close parentheses, divided by 7.5. Now to get angle A by itself, I would multiply the other side by 7. Now, that's what the sine of A equals. So to figure out what A equals, from that, we press second sine, and you can either type all of that in, or the shortcut is second negative. So second sine to go backwards to the angle, second negative to not have to retype that. And we get that angle A is 38.6 degrees. Now I know angle B as well. I do 180 minus the two angles that I have, and there is angle B. And what I can tell, the largest angle is opposite the largest side, and so on. And there's the law of cosines.